Okay, hello everyone. Let us continue the third part of today's class. Okay, let us continue. Okay, this part. Okay, this solution. Sorry. Okay, so let me align this equation at the equality. Okay, and let me make this become white. Okay, and add equation number 8 here. Okay, very perfect. Okay, finally substituting equations 7 and 8 into equation 3, we get, okay, so let us see equation 3. Okay, equation 3 is here. Okay, let me copy this equation and then paste here. Okay, equation 3 is equal to this equation. But we know that the first time, okay, in the expectation, it is equal to this term. Okay, so I copy this and paste this here. Okay, like this. And for the second term, let me copy equation 8 and replace the original term. Okay, so finally, okay, I call this equation 9. Okay, good. So we have completed the solution. Completed the solution. Okay, wait a minute. Let us check the correctness of this equation. Equation 3 is equal to 1 over 2 times the expectation summation ij zi minus mu I times rzz inverse ij. Okay, I delete the comma here. Okay, which is conform because in the slides, okay, page 89, okay, we do not have a comma here. Okay, and plus 1 over 2 natural log 2 pi to the power of nr times the determinant of rzz. Okay, let me add a bracket here. Okay, add a bracket here. Okay, good. Why? Because in the slides we have a bracket here. Okay, so we have finished derived the equation B. Okay, do you have any problems? Okay, if you do not have any problems, let us save it. Okay, this is page 89, problem 2. And save this to the blackboard memo. Okay, good. Okay, so in the next equation, okay, let me show you. Okay, we have derived the equation B, and in equation C we can see that it is equal to 1 over 2 summation ij of expectation of zj minus mu j times zi minus mu I and times rzz inverse of ij. Please note that this term is out of the expectation. Okay, plus 1 over 2 natural log of 2 pi to the power of nr times the determinant of rzz. Okay, so let us see how to derive equation C here. So please see the blackboard, and again I do not have blackboard, so I use the Microsoft Word instead. Okay, chapter 2, page 89, problem 3, derive equation C. Oh, C. Okay, solution. Okay, first let us review equation B is. Okay, let us make the problem 3 boldface and the solution. Okay, boldface. Okay, equation B is equal to this equation. Okay, let me copy this and paste here. Okay, so it is equal to this equation. Okay, so it is equation 1. Okay, good. So it is not difficult to derive equation C. Let me show you. Interchanging the order of expectation and summation ij. Okay, summation ij. Okay, here. Okay, summation ij. Okay, italic. How can I delete this one? Okay, I cannot. So please never mind. Okay, so we get. Okay, equation 1 is equal to first is 1 over 2, and second is the summation ij. Okay, this term summation ij, and I add a bracket here, summation ij, and the expectation. Okay, expectation here, and I add a big bracket here. Okay, and I copy this term to here. Okay, and the second term remains the same. Oops, the natural log is not italic. Okay, so this, oh sorry, so this is equation 2. Okay, so let me check. Okay, equation 1 is equal to 1 over 2 times summation ij, and of the expectation of zi minus mu I times RZZ inverse IJ times ZJ minus mu J and plus 1 over 2 natural log. Oh, sorry, I missed a natural log here. Okay, natural log of 2 pi to the power of nr times the determinant of RZZ. Good. Okay, so next, okay, because Zi minus mu I, okay, and RZZ inverse IJ and ZJ minus mu J are all scalars according to the commutative property. Okay, do you know what is the commutative property? Okay, it states that x times y is equal to y times x. Okay, so in Chinese, it is 交换律. Okay, so equation 2 can be rewritten as, okay, equation 2 is equal to, okay, this. Okay, like this. Oh, no, not this. Okay, equation 2 is equal to this. Okay. Okay, so I can move the term Zj minus mu J, okay, in front of Zi minus mu I. Okay, and the result will be the same. Okay, so I call this equation 3. Okay, and finally, because RZZ inverse IJ, okay, is a constant, it can be moved out of the expectation. Okay, this is an expectation, and I add a big bracket here. Okay, and I add a dot here. Okay. Okay, then equation, okay, this is equation 3. Equation 3. So I can move this term RZZ inverse IJ out of the expectation to here. Okay, so it is very convenient. Oh, sorry, the natural log should not be in italic. This is the same. Okay, so I call this equation 4. Okay, good. And this completes the solution. Okay, do you have any questions? Okay, let me check the last equation again. Okay, equation 3 is equal to 1 over 2 summation ij expectation Zj minus mu J times zi minus mu I, and out of the expectation is rzz inverse ij plus 1 over 2 natural log of 2 pi to the power of nr times the determinant of rzz. Okay, good. So let us save this document. Page 89, problem 3. Okay, to the blackboard of MIMO. Okay. So let us back to the slides. So at this point we have derived C. Okay, equation C. Okay. So next we are going to derive equation D. We can see before the derivation we can see that the equation D is equal to 1 over 2 summation ij rzzji times rzzz inverse ij plus 1 over 2 natural log 2 pi to the power of nr times the determinant of rzz. Okay. Okay, so please see the blackboard. Okay, and again, I do not have blackboard here. So let me use the Microsoft Word instead. Chapter 2, page 89. Problem 4. Derive equation D. Okay. Solution. Okay, equation C. C is. Okay. Let's make problem 4 both face and the solution both face. Okay. So let me copy the equation C from the slides and paste to the Word. So this is the equation C. Okay. I call this equation 1. Okay. So then according to equation 2.23. Okay, what is equation 2.23? Let me show you. Okay, in equation 2.23, we defined RZZ, which is the covariance matrix of Z given by RZZ, is defined as the expectation of Z minus mu times Z minus mu transpose. Okay, so let us copy this equation and paste here. Okay, good. So this is equal to the expectation. Okay, expectation and a big bracket. Okay, and parenthesis. Okay, and I need to replace Z turn by turn. So first let me make a bracket. Okay, so this is Z1 to ZNR. Okay, like this, Z1 to ZNR, and a transpose, and minus, okay, mu1 to mu nr. Okay, so this should be mu. Oh, mu. Oh, okay. So I can copy this mu here and not boldface. Okay, mu. So this should be mu here. And this should be the minus sign here. Okay, like this. Okay, and times itself again. Okay, so I copy this again and add a transpose here. Okay, like this. Okay, so I need to align at the equality. Okay, equally sign. Okay, very good. So next, okay, it is equal to the expectation again, and the big bracket again, and the first term will become a column vector. Okay, so I need a bracket and I need 3 elements here. Okay, 3 elements. So the first element is z1. Okay, minus, oops, minus, not this. I need a minus z1 minus mu1. Okay, here. And the second term must be a dots, a vertical dots. And the finally term will be znr. Okay, znr minus, or not this, minus, okay, minus the mu nr. Okay, mu nr. Okay, like this. And this vector obviously is a row vector. Okay, so I need a bracket again, and z1 minus mu1, and comma, dots, and znr minus mu nr. Okay, like this. Okay, align at the equality sign. Good. And finally, okay, it is equal to, we can multiply this vector by this vector, and we will have a matrix. Okay, please see the following equation. Okay, expectation and a big bracket and a matrix. Okay, so I need a bracket and a 3 by 3 matrix. Okay, like this. Okay, so first term is the z1 minus mu1. Okay, and parenthesis and square. Oh, sorry, square. Okay, like this. And the first element is dots, are dots. And the final element is z1 minus mu1. Okay, times parenthesis znr minus mu nr. Okay, like this. Okay, and for the second row, the first elements are dots. Okay, vertical dots, and then diagonal dots and vertical dots. And for the last row, okay, the first element should be ZNR. Okay, it is 25 minutes. Okay, see you next time. Goodbye.